We can use heats of formation to calculate the heat of reaction of a reaction. Not a formation reaction, this is a plain old reaction. So if I have this chemical reaction I'm trying to find the heat of reaction for, I'm looking for ethane burning or combusting, combining with oxygen, to produce carbon dioxide and water. And I'm looking for the heat of reaction of this. I can't really do this in a calorimeter, but I can find the heat of reaction by using the heats of formation of these chemicals. Notice, this reaction is not with 1 mole of anything necessarily. It does have 1 mole of ethane. Ethane, by the way, is a chemical that is found in natural gas along with methane. About 20% of natural gas is ethane. And so this is an important reaction. Well, how much energy comes from the combusting of this? And really it's heat of reaction per mole of ethane. So I'm going to write these heats of formation. If I notice, I can write the heat of formation or the formation reaction for carbon dioxide. So we have the formation reaction of the carbon dioxide, and I can look up the heat of formation of this as being exothermic negative 393.5 kilojoules per mole of carbon dioxide. I can do the same thing here for the water produced from hydrogen and oxygen, in their natural form as gases. And I can look up the heat of formation of that. It's exothermic, negative 241.4 kilojoules per mole. Again, the negative just means exothermic or energy is produced. I now need the heat of formation of the ethane. But in order to do that, I need ethane on the reactant side. So I'm going to write the forward reaction, but in reverse. Basically a decomposition reaction. So that my ethane is on the reactant side, so I can use Hess's law. So I write this ethane, I write it as reverse, and since I wrote it as a reverse formation reaction, I need to change the sign of the formation energy. In other words, I need the opposite. Since I flipped the reaction, I need to flip the energy. And so I get the opposite of negative 84.0 kilojoules per mole. In other words, this one is going to be endothermic. I can now combine my reactions, Hess's law, to see if I can come up with my net reaction. But in order to do that, I need to notice, in my net reaction, I need 2 carbon dioxides. So I need to go ahead and do this reaction twice. I need 3 waters, so I need to do this reaction 3 times. And I need to do the ethane only once, so I don't need to do anything to that. I can now look and see if any of my compounds cancel out. I can see here I have 2 carbons, which will cancel out. I have 3 hydrogens, which will cancel out. I'm left now with 2 oxygens and 3 half oxygens, which totals up to be 7 halves oxygen. Great. I have 2 carbon dioxides. I have 3 waters. Excellent. And I have 1 ethane. Now notice, in this whole deal, I don't need to include this oxygen because that's an element in its natural state and doesn't have any heat of formation. I can now go ahead and add these together. 2 times this, plus 3 times this, plus the opposite of this, to get my heat of reaction, my total Hess's law, add them up, it's a state function, to get my total energy. And my sum comes out to be negative 1427.2 kilojoules. Notice this is not kilojoules per mole because now we've summed all these up and it's not per mole of anything. In addition, you're asking about significant figures. Notice this has 1 decimal place. Since we are adding all these together, and I see my originals have 1 decimal place, I'm going to line up that decimal, I'm going to end up with 1 decimal place in my answer. Not the total number of significant figures, but we're adding, so we need 1 decimal place in our 1 decimal place for our significant figures. So my answer, my heat of reaction here, would be negative 1427.2 kilojoules. I've used the heat formation of the compounds in the original reaction, leaving out O2 because that's in its natural state, has no heat of formation, and used Hess's law to combine them to get my equation of interest and my heat of reaction. To summarize this, what we've done is we've taken 2 times this heat of formation, plus 3 times this heat of formation, plus 1 times this heat of formation, or the opposite of that. We can simplify this, and we can actually simplify this in every situation to be the heat of reaction is going to be the sum, this is a Greek letter sigma, which means summation, the sum of all the heats of formation of the products times their coefficient, so add those together, minus the sum of the heats of formation of the reactants times their coefficient. We can always do this just by simply looking up the numbers for these values in the table. Understanding once again, this is a 0. So we're going to add these two together to be here, add these two together to be here, making sure to multiply by the coefficients, and we'll come up with an answer of the heat of reaction. We don't have to do the whole Hess's law thing to come up with this result. Just know this equation. Another way to get heat of reaction.